It's time to go. Stand here. Can we see them? Can we get their faces up just to introduce? Okay, I guess got it. Patrick and Ursula, we are ready to go. You can't see me, but I am Natalie. I am here. Thank you for joining us. Thank you everybody for coming today in person with your punch cards. I'm very happy to arrange this panel with people I work with regularly who do some of the best known work on conflict around the world. We're going to start. I'm going to be introducing because I want to do myself. So very quickly, Dr. Abraham Flaxman will be our first presenter. He is an associate professor of global health and health evaluation sciences at UW and he's going to be talking about the Iraq mortality study that he worked on with our other presenter, who is Dr. Amy Sofian. She's a professor emeritus of global health and health systems and population health from UW School of Public Health. We also have, coming from afar, Dr. Ursula Torrisi. Ursula, oh, you're not on the big screen. You will see her in a few minutes. Dr. Torrisi is a postdoctoral associate at NYU Abu Dhabi and imminently moving to be a assistant professor of sociology at McGill University in Canada. And she's going to be talking about one of her studies of conflict, and that's the mortality, estimating mortality in the area. And then last, we have Dr. Patrick Hoiveling. He is a professor of sociology at UCLA and works closely with their population center. And he'll be talking about estimations of mortality during the Khmer regime in Cambodia. So with no further ado, AB is up first.
Thank you so much for that introduction. Thank you to the organizers. Thank you to my co-panelists. And my hope is that this will soon be sharing the screen too. Perfect. And so now people in the room who have been seeing this and people who are on Zoom can all see the same thing, which is a slide that says estimation of mortality during armed conflict, some methods and data. That is, oh, I can do that from here. Except I have to click on reclaim host or stay co-host to make that go away. Mouse goes when it's over there. Stay co-host. Boop. So I will begin with land acknowledgement of this research conducted on the traditional lands of the Coast Salish people. It'd be cool if I could see it in front of me. I'll stand here so the mic can hear me for Zoom, and look here so that I can see what's on the slides. Here are some disclosures. I guess the important thing about this is I haven't found anyone to pay for research on mortality during armed conflict specifically. So if you have any leads for that, I would be interested. I am in part here because I work at the Institute for Health Metrics and Evaluation, which is the sort of center for the global burden of disease study. When you think about the global burden of disease study, imagine a tree map. I don't usually use this gratuitous 3D version of the tree map, but I like it for these purposes because the illustrators of it really called out the tiny little wedge in there that's the burden of war. And you can see that I kind of adjusted their number because when they made this graphic 10 years ago, they said it's so small, it's less than 0.1%. If you go to the IHME website now that has our most recent update, it's more than 0.1%, but it's still quite small. And so one of the reasons that the other esteemed members of this panel like to, criticize our work is because that seems wrong, doesn't it? And so this is global, all ages. And if you focus in on particular places, conflict and what we call it in the global burden of disease, conflict and terrorism, but for the purposes of this talk, armed conflict, can be a major part of the mortality burden. this showing, for example, in Sudan, that 25% of deaths were from armed conflict at the height of the conflict there. And I've focused in here on ages 15 to 49 because these are the ages where, wouldn't it be nice if there were 0 deaths? So dealing with war as a public health threat would have been a way to avoid a quarter of the deaths happening in Sudan at that time. So I'm going to just overview for you, and then you'll have 3 panelists that give you a really cool, deep look at different ways of doing this. But from the global burden of disease approach, we're trying to take all the available evidence, put it all together, and there are really 3 broad categories of evidence that go into these conflicts. And it also is important to distinguish what are we trying to estimate about these things, because in the global burden of disease work, there's 2 parts. The mortality from any cause, which might be what we were thinking of in the panel, armed mortality during conflict, and then cause-specific mortality, how much of that is actually caused by armed conflict versus maybe, let's say, directly caused versus indirectly caused, like wouldn't have happened if there wasn't a war, but was because someone had a heart attack and couldn't get emergency services, not directly from some kind of bombing or war-related injury. The 3 sources, broadly categorized, and have fun picking apart these taxonomies because it is hard to group things up. I'm going to convince you, is administrative data sources. And in this part, I'm especially thinking of death certificates, term of art for that, CRVS. And I'm also going to call censuses administrative sources, if panelists object to that. We'll talk about it as we go. To be contrasted with data source sort of category 2, survey data, and that's what you'll be hearing about from Professor Hagopian. And the data source 3 is what I'm going to put in scare quotes, a sort of big data approach that in conflict mortality is often called passive surveillance. But whether we call this big data or passive surveillance, what it's really getting at is like using things like news reports or eyewitness accounts, or I guess what in the epidemiology department they call bad data, convenience samples, to try to figure something out. So a picture from global burden of disease work showing how hard this is the adult mortality rate in Iraq over time. And you can see a circle in the early 1970s showing data from a survey, and triangles in the later 1970s showing data from those death certification systems, vital registration. And then the data in the late 90s and early 2000s comes from a household survey. And in part, I'm showing this to tee up Amy's work because as fun as it is to bring together all these different data sources and try to do clever things with big data, there's often nothing better than going and asking and getting more data from a representative sample. Note from online that I should keep talking into the mics. I will try. So one thing that is kind of fun to think about is trade-offs in these different data sources. This is an idea that I trace to movie making, but others have other origins for it. Would you like your movie or your analysis to be good, fast, or cheap? You can pick 2 of those at most. For example, if you want things to be good and fast, which by this case I mean like updated in real time, perhaps having a functioning vital registration system in place before war that you were able to keep running during the conflict is the way you're going to do that. It's not cheap. I group census into that too. We can talk about whether that's fast or not, but it's also not cheap. And on the other hand, surveys are good, and they're not cheap. Like, it'd be great to have someone pay for it, but compared to running a census for $15 billion, a survey is cheap. So that's what I said you can do. You don't need to be fast because it really helps to wait until the height of conflict has receded to send people out and do a survey. Professor Hagopian will tell you more about what it's like to do that before it's quite time also. And then that third one that I called passive surveillance or a big data approach is fast and cheap. It's just probably missing a lot because we're only getting to hear about what has been observed in this convenient sample. And so I think to leave it off, one of the things that gets really interesting is comparing these different approaches against each other. And this slide is a very recent one from a paper in Lancet. I wasn't involved in it, but I think it's so cool that I couldn't help but show it to you, looking at what's happening during the current conflict in Gaza. And there have been reports from the Ministry of Health where they've been able to say, this is what our death certification system is telling us about deaths over time. And there's been a lot of skepticism about those reports. Just look at the news about what's happening in Gaza. How can the Ministry of Health possibly be seeing what's happening there? Well, a very clever sort of big data approach came from this group at Hopkins that said, we can compare the total mortality rate from those Ministry of Health reports with the total mortality rate from situation reports talking specifically about employees of this UN agency, UNRWA. And you can see how in red, there's a sort of increasing cumulative reported death rate that comes from Ministry of Health reports, and overlaid in blue is something that's in the same ballpark from those UNRWA situation reports that they analyzed in this same comparable rate space for this. The takeaway from this, the title of their paper, was no evidence of inflated mortality reporting from Gaza Ministry of Health. I think if you're willing to hypothesize that UNRWA, which has a large workforce, is getting exposed to similar rates of mortality as the general population, actually the Ministry of Health reporting is probably on the low side. And this ends on November 10th. If you were to try to extrapolate out from this, the Ministry of Health says there have been 25,000 deaths. That's probably at this point a more and more underestimate of what's happening. This stuff is all a bummer, so I'm going to leave it there, except for showing you a picture of puppies and turn it over to our moderator or straight to our next speaker? Straight to our next speaker. I've stopped sharing, and once Ursula shares, then we'll make sure that we can all see it on the big.
Can you see? Can you see me, hear me? I'm not sure.
Is this sufficient? It's not ideal, I know.
Right, someone told me that you can see me and hear me. I'm not sure if I can hear you, but that's okay.
Okay, I think you're good to go.
Yeah? Right. All right. Well, thank you very much, Natalie, and all of you for the invite, and good afternoon. My name is Ursula Torizi. I am a postdoctoral researcher at NYU Abu Dhabi, where it's currently well past midnight, but being part of this panel is absolutely a well worth reasons to be awake at this time. So I will spend the next 6 to 7 minutes to discuss how we can estimate mortality due to war, conflict, and violence with one of the sources that AB just talked about. Perhaps the simplest, or maybe better said, what we as demographers would consider as the gold standard data, that is vital statistics. And just so you know already, this is pretty rare to have in conflict settings. So I will just explain you what we did with my colleague Ariel Karolinsky at the Hebrew University for the case of the second Nagorno-Karabakh war between Armenia and Azerbaijan that took place in 2020. So just to get started, I also want to give you a bit of a background about how this sort of studies sometimes come up. So at that time, in 2020, I was a PhD student at the LSE in the UK, and I was studying the consequences of the first Nagorno-Karabakh conflict on family dynamics. Whereas Ariel had started perhaps one of the most, I would say, important data gathering projects on the COVID-19 pandemic, the World Mortality Data Set, which is an open data set that tracks all-cause mortality data from around the world. And when the war erupted in September 2020, as in most cases, even for the least known conflicts, a good amount of claims were made on either side about casualties suffered, but more importantly, inflicted to the opponent in this specific case. And for our different reasons, both me and Ariel became very concerned about these numbers, claims, and interested in verifying them. But we actually did not know each other at all until actually another friend and demographers figured out that we were both talking about the same numbers and things to him, and puts us in touch via Twitter. And this is an example of the actual example of the text that we got that put us in touch. And so this is just to show you how sometimes this type of research also emerges, especially for this pretty unknown conflicts. And so we decided to join forces, me and Ariel, to attempt to really try to verify the claims, and more broadly to really try to get an independent estimate of how many lives were lost during this pretty short-lived conflict. It was about 44 days war, but was very intense between Armenia and Azerbaijan over this area that you see in blue and kind of reddish in the map that is called Nagorno-Karabakh. But the question was, as always, is how are we going to do this? And you need to know that both Armenia and Azerbaijan are not particularly well-studied countries. More generally, a lot of war-prone and war-affected countries aren't very well-studied. And one of the reasons here is that data from both of these countries is scarce. And Azerbaijan in particular has been historically quite secretive with its data. It has rarely released any to the public. And when it did so, it really did it only in very highly aggregate formats, for example, publishing yearly total counts of births or deaths just in an aggregate format in the country. And also Nagorno-Karabakh is not an internationally recognized state or entity, and which kind of puts its authorities in the interesting position of not having to disclose anything about their demographics to anyone. But perhaps the one of the few good things that happened during the pandemic was that in 2020, actually for the first time, both Armenia and Azerbaijan published their demographic yearbooks that are essentially their vital statistics data, which are the data that we as demographers really need and want to have to analyze demographic trends and patterns. And you know, probably very well, vital statistics essentially consist of specific counts of births and, importantly for us, deaths that at this time came disaggregated by age and sex, as well as very broad cause, and for a period long enough to generate baseline comparisons. And so we use those data to do a very kind of simple exercise. We calculated something that I'm sure you're probably now all kind of familiar or have heard about, that is excess mortality. And in very simple terms here, excess mortality indicates the number of deaths from all causes during a crisis, and in this case, a war, above and beyond what we would have expected to see under normal conditions. And so excess mortality is a pretty comprehensive measure of the total impact of a crisis, because it captures the number of confirmed deaths, but also crisis attributable deaths, for example, those that are not diagnosed or reported, or not indirect deaths that are still due to the overall crisis conditions. And also excess mortality is pretty straightforward to analyze and to calculate, because it really, once we have the data, because it's just simply the difference between the reported number of deaths for our interest period, in our case was 2020, and a counterfactual that is essentially an estimate of the expected deaths for that period had the war not happened. So in our case, we had vital registration data that allowed us to use age and sex death counts from 2015 to 2019 as a baseline. And so just to show you how we do this type of exercise and analysis, here I'm showing you the deaths for Armenia that we would have expected to observe in 2020 if the war didn't happen or nothing or no crisis happened. And so if essentially the mortality in 2020 followed the historical trends between 2015 and 2019. And now here with this red dots, instead showing what was actually observed. And as you can see, female deaths were pretty much in line with what the historical trends would have predicted. And in contrast, we find that male deaths diverge significantly from the expected values. And this sort of difference emerges around age 15 to 19, most likely 18 to 19, and up until age 45, 49. And a very similar patterns is observed also in Azerbaijan. So essentially with simple vital registration data that we do a lot of tests to see whether they were good, but we are able to see and observe that for some age groups in 2020, both countries experienced some significant excess in mortality. Of course, though, we all know that 2020 was a peculiar year. It was a serious COVID period. And so we use other vital registration data or other information in the vital registration to sort of try to figure out whether our excess estimates were really most likely due to conflict. So in fact, for example, we compared with vital registration information from Georgia, and as you can see, we couldn't see any of the same pattern there. We also looked at causes of death that were more preventable, that usually are sort of more prevalent, in the age sex groups where we observed the excess mortality. And again, for 2020, we don't find any particular trend. Actually, we see that, for example, road traffic accident declined because most likely of the lockdowns. So overall, we estimated that about 6,000 or more extra deaths happened in the population aged 15 to 49 in Armenia and Azerbaijan in just over a month of war. And for this sort of small countries, these are pretty big numbers. And to put them in perspective, for example, the number of deaths that we observe for late teenagers in Armenia is pretty much equal to the amount of deaths in that age group that we would have observed in over almost 11 years. Before I close, I just want to say and remind you that we got very lucky. We were able to work with gold standard data and do pretty similar, easy analysis. But this data is usually extremely rare in conflict and post-conflict settings. And is also quite prone to inaccuracies, particularly in low and middle income countries where perhaps the infrastructure is not as reliable. So really even building the baseline information is very hard. And of course, since vital registration data can be quite easily manipulated by governments and inflated, or data might be underreported, and this is something that really depends on the nature of the conflict. And I think AB just mentioned this briefly, so I'm not going to discuss this, but an example of this type of debate is what's going on in Gaza, where here there is, I'm actually referencing to another study that has been published in The Lancet that actually, again, also suggested and used a similar strategy to the one that we use, sort of only used 2021 as a baseline to check the mortality reports that were being made by the Palestinian Ministry of Health. And in the end, also suggested that data there was of reasonable quality, especially for the ages of 25 and 59. And another example, just very quickly, that I wanted to give to you is this study about excess mortality that was just conducted by a colleague in Germany and Ukrainian media sources, where they don't use vital registration data, but they use a different similar type of, potentially technically similar type of data. They use records of inheritance cases filed with the Russian authorities to try to estimate excess mortality among male soldiers. And they get to a quite credible number of about almost 100,000 deaths. And just in case, if you're interested in trying to figure out how to do these things, we also have all our replication files for our study on GitHub, and that could be perhaps a good starting point for people that are interested in looking at mortality and excess mortality with vital registration data. Thank you.
Slide here. Oh, you're good to go. Can people online hear me? Let me see. Yeah. Now can people hear me online? No.
Yes.
Okay. What's that? Yeah, okay. You're right, that was premature. Okay.
There we go.
Is that working? Okay, great. All right. Everything working okay? It's a miracle. That's why they pay me for the IT work. All right, so thanks for having me. AB and I worked on a mortality study in Iraq back in 2011 to 2013, and I'm going to tell you some stories from that project. Mostly, I'm not going to share results so much as processes. Okay. So I'm just going to comment that while we are talking about war mortality today, probably the non-lethal harms of war outnumber the fatalities of war in most settings. And as the pirates say, thems that die are often the lucky ones. And measuring death, of course, among American soldiers is pretty straightforward. But how do we know how many died among the enemy as we think of Iraqis, right? So easy to Google that, but where do those numbers come from? Secretary Rumsfeld told us early in the war that the US Army doesn't do body counts, which of course turned out to be a lie when we found the WikiLeaks reports of US Army counting of bodies. And I'll say more about that in a minute. And I'm guessing my colleagues here who do big, complicated projects are familiar with the idea that every big project starts with some smaller introductory efforts, sometimes just to get to know the people and the landscape and the topics a bit. And in our case, some UW folks created a sister university partnership with the University of Basra and worked with them to evaluate their leukemia data in about 2009. We published that in the American Journal of Public Health. And I'll just say that in the course of doing that work, we befriended some people whose lives we followed in an acute way. Riyad Lafta became our friend who traveled to Basra and helped us gather these data on leukemia. And after he started working with us, there was a car bomb exploding at his university, Mustansiriya. And we wrote to him asking about his well-being and exchanged many similar check-ins over the course of the war. Before our 2011 study, there were 5 population-based surveys to attempt to measure war-related deaths in Iraq subsequent to the US-led invasion in 2003. 2 of those, the Roberts and Burnham study, were sort of precursors to ours in terms of the same people and the same methods. And the finished product always makes the process look smooth and irons out the drama. There was a little bit of drama involved, and that's what I want to talk about today. All of the academics on this project, as A.B. noted, worked for free, which meant they had day jobs to pay the rent and were doing this on the side. On the upside, there were no donors or funders to mess with our processes. I guess that's the one upside. Because our Hopkins partner could not serve as PI on this project after a kerfuffle involving his 2006 paper, I was asked to take over the lead on the project. It was definitely the most challenging research project of my career, and I've done some challenging projects. Our team met in Erbil in northern Iraq in March of 2011, and again after the data collection was complete in September, and the relationships we formed over the course of this study have been lifelong and deeply meaningful. Remember Skype? We used to do a lot of 6 a.m. phone calls using Skype. It was kind of a miracle then, even then. Ursula talked about sort of the formula for calculating expected and observed deaths and doing the subtraction. We collected in households that we stopped at both numerator and denominator data so that we could create death rates and apply those to population figures to get a final body count. Good population count data can be very hard to find in war zones. IRB approval was seriously difficult. RUW IRB processes back then were much more burdensome than they are now. That is one thing at UW that has improved over the last decade. And I had to get some outside ethicists to help us get through the IRB reviewers. The UW wanted the enumerators in our survey collection team to announce at the door that they were working for a US university. Can you imagine? Our data collectors viewed that as a potential death sentence for themselves. We also got IRB approvals in Iraq and at Hopkins. And when the results came out of the 2 precursor studies to this one, we attracted a troll, this guy, Michael Spaggett, and his team emerged after Gil Burnham published his study in 2006 in The Lancet. Spaggett is an economist. No derogatory thoughts about that, right? And you can see none of his colleagues on this critical piece were epidemiologists or demographers, and yet their voice was outsized in critiquing the study with a special focus on the sampling methods of those 2 previous studies. Because of the criticism of the Roberts and Burnham papers in The Lancet, we decided to focus on improvements to the sampling method for this 3rd attempt. Lindsay Galway, PhD student at Simon Fraser, led this design work with her supervisor, Tim Tuccaro. And I won't get into the details here, but we used this fancy Google Earth software product and dropped grids and then randomly drop pins to choose neighborhoods and then starting households. And when we were in Erbil in March, that's our team there, trying to find the start households using the maps that were generated for this process, and it worked. It was kind of amazing. Nonetheless, here comes Mr. Spaggett again after our project was published. And he had a whole new set of complaints, mostly around things that turned out not to be true, like he thought we should weight our data when it was actually population proportionate to size. But we'll just say this sort of work doesn't attract money, but does attract trolls. Is that fair enough to say? Okay. So our household survey collected information from the head of each household about who lived there, who'd been born there since 2001, and who had died. We asked about cause of death, and in this way, we learned about the status of 10,500 household members. We also asked every adult in the household to tell us about their siblings and their status. And in this way, we learned about an additional almost 25,000 people. It's a really efficient way for interviewing just 2,000 households to learn about thousands and thousands of people. The surveying team was recruited by Riyad Lafta from among his recent graduates of Mustansiriya Medical School. These people were brave and diligent and remarkable in their work. Our team met in a hotel room in Erbil in September of 2011 to analyze results. And frankly, our death counts were lower than we had expected based on previous studies. And we had three hypotheses. One, it could have been a sampling error, despite our more sophisticated methods. Two, it could have been a non-sampling error, such as recall bias. And three, the large outmigration of many Iraqi families by 2011, war started in 2003, might have left nobody behind to report on the death status of people in their households. This was our colleague Sahara, who looks happy in this photo, but there were a lot of tears shed about the perceived undercount. I'm showing this because this was a portrayal of data from the WikiLeaks discoveries. And to explore the possibility that we had a sampling error, we looked at the WikiLeaks data. The red spots show high intensity mortality to see, did we oversample low intensity areas? We concluded probably that wasn't the problem. And so we moved on to a migration adjustment. And there were no real papers in the literature about how to do a migration adjustment. So we came up with a method that maybe worked. And then AB came up with these amazing ways of portraying the death data. The solid red are deaths caused by violence, war-related. The pink are excess deaths, but not direct war-related, like cancer, heart attacks, more than we would have expected. And the gray were expected deaths pre-war. And just show you a couple more. These are in the paper if you want to go find them. We published our field manual with this paper, which is an accompanying file if you want to go find that. I was very proud of this way that we portrayed all of our methods in a very transparent way. And here's Riyad and Lindsay and Erbil, and our team standing on the steps, Riyad and Lindsay with me. Riyad Lafta finally made it to the United States in 2016. He came to Seattle for a visit, and then we went to Denver together for the American Public Health Association, and he presented there. It's wonderful that these relationships have lasted all these years. I've seen him since in Beirut, and we remain friends. It's not a lucrative line of work for those of you looking for, you know, a well-lubricated career, but you do meet the best people and have the most fun, in my opinion. And this was our group way back in 2003 in the Department of Global Health with our banner at local anti-war marches. Okay, so who's next? It's online people, right? Patrick. Okay. Thanks, everybody. So we're going to let Patrick go now, right? And I'm going to get out of there. And you want me to hand to Chris, probably.
Are you seeing the screen?
Yeah.
Okay. Let me know if when you're ready, I'm ready.
Yeah, right. We're ready for you.
Okay. Well, good afternoon, and thanks for the invitation on this exciting panel. So I'm going to talk about one of the methods to estimate mortality during civil conflict, especially in situations where none of the previous methods are available, in the sense of there's no vital registration, there's no specific survey. But there is some estimate on population figures, and you can then use methods called demographic reconstruction to try to estimate the mortality. So I'm going to start rather unusually. For me, I usually jump right into equations and numbers, but I'll try to ease into this. I'm going to read a quote. I don't know if it's readable from on the screen, so I'm going to read it despite my accent as a non-English speaker. It's for Margaret Drabble, The Gates of Ivory, a novel from 1991. Stephen records that between 12 and 32 million died there. He has underlined the word between heavily. He has also noted the 20th century deaths of 800,000 Armenians, 6 million Jews, about 3 million in Bangladesh, some 20 million in the labor camps of the Soviet Union, 2 million in Vietnam, and between 1 and 3 million in Cambodia. The words between, about, and some are all underlined in red ink. And with reason, thinks Liz. Between 12 and 30 million killed is a phrase that cannot exist. What kind of history, what kind of mathematics is this? What has happened to those spare tens of millions? And I like this quote because it's putting in more vibrant prose that I would be able to come up with. Both the rationale and the limitation of the approach I'm going to discuss, which is demographic reconstruction. The rationale is that as the narrator in this novel is thinking, people don't disappear. So if people are counting at some point before armed conflict, they are you can either count them after conflict has ended, or one of few things have happened. They have either migrated out or they've died during the conflict. And so the way that the demographers capture this is well, I thought I was in this mode. So let me go down. So this is captured by this accounting identity that demographers know as the balancing equation of population change, which is basically if you have people at time 0, which is before any time you have a population count before civil conflict, you can either find these people after the conflict at a later time t, after subtracting people who were born in between or migrated in the country. Usually it's few people migrate into a country where there is civil conflict, armed conflict. And if they're not in that count of people after, then they are either dead or they out-migrated. And in a manner that is similar to what Ursula's presented, we can actually think of those deaths as both the deaths that were expected, that would have been expected even in the absence of armed conflict, and a number of excess deaths that are unexpected and that we will attribute to conflict. So if we manipulate those terms in this equation of population change, we can calculate the number of excess deaths as a residual in this sum and difference of terms, the difference between the number of people that were already present in the population, those who were born in the interval, those who were migrants into the population in the interval, minus those who were still there at the later time, those who were expected to die, and those who migrated out. So this is a residual estimation methods, again, capturing this idea that people don't disappear, so they have to be somewhere in this equation as one of those terms. But there's a number of terms, and the accuracy of that term, the estimate you can get on the left-hand side, is depending on how good the counts on and the flows that you estimate on the other side. And that's one of the limitations of that approach. That's maybe the main limitation. So uncertainty can be substantial because any uncertainty about migration or population size will be affecting the quality of your estimates. So it can be often substantial. It depends a lot on the time period, the length of the time period for which you try to carry that reconstruction. But I would say this method is only suited in some kind of desperate case, both desperate on the side of data, you don't have many good alternatives, and desperate because the situation has to be pretty dire. That is the amount of excess mortality has to be substantial, quite substantial, not to be lost in the noise of the estimation. One way to try to convey this this uncertainty is what we can describe here as a fan when you do a reconstruction. This is the example from my study in Cambodia, where the last census before the 1975-1979 conflict was in 1962. And just to estimate population projection to forward over a period of about 15 years, there's a lot of uncertainty, and because even past demographic trends are not known exactly. So there is already quite a large uncertainty about the population size before the conflict. And likewise, after the conflict, there wasn't a census until the end of the 1990s. But in this study, I used 1992 electoral list to try to get a sense of the population afterwards. And it's maybe less intuitive if you're not a demographer, but the same way that you can carry forward population projection by estimating how many people will be born in the population, how many people would die, and how many people would migrate. You can do the same work backward, trying to estimate how many people had to be there in 1980 to produce that population in 1992. So you see that if you're trying to connect the dot here, and basically the difference between the backward and the forward reconstruction is your estimates of excess deaths, it can vary a lot between the smallest, the closest to curve, and the furthest away. One of the advantages, though, of that method is while uncertainty is definitely substantial, it is quantifiable, which is not always the case with other approach. Often with other approaches, what you have is a kind of a best estimate, but it's really hard to estimate how sure you are about the quality. You can usually with survey data, but survey data have to make assumptions about how representative the population is and how the errors are distributed and so on, which are usually difficult to do in conflict situation. So this is an example, for example, from my work in Cambodia, where I tried to estimate the distribution of potential estimates. Instead of taking one number for the number of, say, births or the population size, I try to define a distribution of possible population sizes, number of births, etc., and draw from that to get a distribution of excess deaths. And you can see what I meant with the substantial uncertainty, that even to get something like 60%, 66% confidence interval, which is something like a 1 plus or minus 1 standard deviation. If you're using a normal curve, you have to take estimate ranging from 1.6 million to 2.3 million. So this is a fairly and that's only giving you only 2/3 likelihood of being correct, with an interval that is fairly large of, say, 700,000. So I think it's useful in this case because there were about 2 million, something in the order of 2 million deaths, which is quite enormous for a population of 8 million. But it wouldn't work if for more typical level of mortality that are in only a few percent of the population. However, even with this method, we are able to rule out almost with, certain. I mean, we can show that an estimate below 1 million, and some people have argued that it was less than 1 million, would be less than 1% likely, and more than 3 million, which was also one estimate of the government at the time, would be less than 1% likely. So it's not very precise, but it's still useful to rule out some of the extreme estimates I didn't show you the whole gamut of estimate that we produced at the time, but the quote from Margaret Drabble when saying between 1 and 3 million, those were actually existing estimates at the time. Another limitation is that you don't really have a cause of death breakdown. So often we would like to know if mortality has increased, is it as a result of violent deaths, people who are directly involved in armed conflict, or is it something indirectly related to the disruption that the conflict has induced? We cannot do that breakdown, but we can infer something of a breakdown by looking at excess deaths by age. Excess deaths from war and combat casualties have a very different age structure. So here, for example, is the usually a very different age structure from normal deaths, or expected deaths, which usually follow the J curve, that is somewhat high in infancy and then raising at older ages. And when you look at the male and female mortality here, number of deaths by age, you can see that it's very far from that. So we can actually tease out the deaths that would be more or less following that curve, and we have a new residual of deaths that we can attribute to violent mortality. And we see that they were as often very high for male in the ages of 10 to 25. And then there was also a larger kind of a second mode for female of older men and women who were probably due to more politically motivated type of execution induced by the regime. So yeah, I'm going to stop here because I think I'm already over time.
Thank you, Patrick, and everybody. We are time, so if you need to leave the room, go for it. Patrick and Ursula, are you available to take a few questions?
Sure.
Patrick, Ursula, can you hear me? Are you available to stay for a few more minutes for questions?
Oh, sure, yes.
Sure.
Sorry, who was the question? Okay. Jessica, are you going to do the online questions? Arnie, speak.
Maybe.
Is it written, Jessica? Can you? No, sorry. They will. Can you come up here and read it? They will not be. I think they can't hear unless you're right here.
I think you need to right here. Yeah. So the first question is why the war statistics data is not used in Iraq or Karabakh? Were they not available? And the second question is, in the excess mortality estimation, are we assuming observed deaths data are accurate? If observed deaths are not accurate, then that would change the excess mortality estimation.
Did you guys, Ursula and Patrick?
Yeah.
Who would like to take that? Four of you. AB. AB on a wrap.
Hi, everybody. I think we'll definitely look to our remote guests for these also. But I think that the answer is you can only use what's available. And, you know, when Professor Hagopian's study team went to all these households, people said, oh, yeah, we do have a death certificate. Maybe 9 out of 10 deaths had a death certificate, but there was not the civil infrastructure to report out those death certificates. So as far as what goes into a global mortality database, no, not available. And then regarding this point about excess mortality estimation, I'll be interested to hear what the real demographers have to say, but that's got to be right. If you don't
I'm gonna
have
take
an
that.
accurate number or other number and you subtract them, what's going to come out? Something even less accurate. So I think that's why it is so important that we be able to get these basic informations as accurately as possible, and why we want to trade off things against each other and triangulate between different answers from different methods to see if there's any important inconsistencies between them. Thanks.
Yeah, can I just jump on that? Can you hear me? Great. Yeah, absolutely. I think AB is very right. In our case, for Nagorno-Karabakh, we were quite lucky in a sense that the context for voter registration data also matters a lot. And we were quite lucky to have data from two countries where their historical past somehow had helped to have some relatively accurate data. Not that all Soviet statistics were great, but there was already an infrastructure, and we have had, of course, when you think about using voter registration data, when you have them, which is rare, if you have opportunities to have some kind of other data sources, for example, demographic and health surveys or some other survey, there is always a way to sort of try to check how good the voter registration data you have are. So the best alternative, and this is something that we have done for our work, was to try to really just check whether there were pretty obvious inaccuracies in terms of age patterns, age structures, and compare them with available data. The problem most often is that you maybe don't have those other data sources, that you're already lucky enough to have one survey or have some kind of voter registration data. So you do the best that you can. And I think the best thing we can really do is, one, is to push for more data to be collected in these countries. And secondly, is to be honest with what we are able to do, and not to refrain from doing work when data are scarce, especially now when methods have been evolving, and there are new ways to collect data. And this is just, let me say something. I think researchers in this area have become increasingly imaginative and smart with their data collection methods. There are ways to use, for example, mobile phone surveys, or to use, in fact, new sources of data that people wouldn't think about, as the ones that I showed you for the Russia mortality estimates. Those aren't perfect data, but it's always better than just live stuff unreported. But sure, overall, we want to have as accurate data as possible.
Thank you. Any other questions, Rowan? Can you just come up here? Rowan Arar, the organizer of our whole seminar.
Hi, everyone. Oh, not alone in any capacity. So my question, I was really interested by this approach to asking about siblings in order to get a larger sample size. And of course, my first thought was actually thinking about Gaza and how entire families and lineages have died. And I was curious, given the kind of conflict or war that happens might affect how one samples or how one collects data. Do you have a reading or something that you might guide us to? I'd be really interested to think about how different kinds of conflicts, so let's say in this case it would be like besiegement, where migration isn't possible, or bombardment under conditions of besiegement, might lead to certain kinds of data collection. It would be really interesting to me if I could identify how different kinds of violence that are seen as war shape the kinds of data that we collect. What kinds of questions do we ask depending on the kind of war?
You don't want to answer anything, Amy? So absolutely excellent question. And My source on this is from one of our local experts, Emanuela Gakidu, who's at the Institute for Health Metrics and Evaluation, wrote this paper called 50 Years of War Deaths from Vietnam to Bosnia, or something like that. She wrote it like 20 years ago. So I actually saw her on my way over here and was like, oh, I wish I had time to ask you what's new, but she was on a call and I was coming to make sure the tech was working. And I think it's absolutely astute point. You know, there's just a big difference between what's happening in Nagorno-Karabakh, what's happening in Gaza, what happened in Vietnam or in Congo, or, you know, the situations are wildly different. And so the ways that we're going to be able to measure this are really different. For those of you who haven't heard before, these sibling history methods are really exciting methodological approaches. And we should talk about it more. I'm not going to burn more time telling it, especially if Dr. Hubelein has raised his hand. What have you to add to that?
Well, I will say something about the sibling method. So it's a popular way to try to estimate mortality. Of course, as your question infers, the issue with that is that people are who are at risk of death during the armed conflict are not equally likely to end up in the sample of your siblings, right? So there's a correlation. If there's any correlation or clustering of mortality within sibling, then you have an issue. But I remember that goes back some time that I haven't looked at that for some time. But there is some way though to adjust for this, because you can actually, if you have someone who has five, I mean, if you look at people who have five siblings, how many have 1, 2, 3, 4 that have died, and you realize there is this pattern that is, it's more likely to have two dead siblings than it would be to have one sibling die squared. If you look at these probabilities, you can find a pattern and then you can adjust for that pattern, and you can even infer the zero. That is, you can infer the number of people who have no sibling left and cannot be reported. And this was actually done a long time ago by people who studied migration, because it was also a popular way of studying out migrations to go to origin location and ask people how many of your siblings have moved to abroad and so on. And this was already identified as an issue, that it was also clustering of migration, because you're more likely to migrate if you already have a brother or a sister abroad. So I'm not sure I can track that easily, but I remember Ken Hill has done had a paper on that type of adjustment.
And your colleagues at IHM, don't they have like a book on sibling survival and these kind of corrections at the household level?
I've never seen their book. Did they write the book?
There might be a book. And I think so. Sibling survival methods is pretty well developed. The corrections for SIB-SHIP size and the whole family disappearing. But I think what was interesting about the Iraq mortality studies, you guys also did this migration correction. That's the first time I saw that one. That was a major.
And that, you know, I feel that was enabled by having these, in this case, from a survey, but two different modes of measuring in the survey, because there's a lot more fun math from the social surveying, kind of like, tell me about your siblings. There's another esteemed colleague of ours who works on even broader network sampling. Tell us about all of your friends. And if you can calibrate this, then Tyler McCormick has ways to go broader to your friend network. And instead of, you know, multiplying your sample size by like 2 to 5 for all of your siblings, now you can multiply it by like 10 to 100 for all of your friends, balanced against trying to figure out how many friends people have and all of the biases therein, compared to a much more direct method where we just say, tell us about this household. The problem with the sibling sampling is SIB ships that have no one left to report, or even just only children who don't have anyone in the SIB ship to report on them. The problem with household sampling, which is especially relevant to war or other things that cause great migration, is what if there's no one left in the household to report on it? And so balancing these against each other gave us a way to say, we've got something missing in the household calculation. Let's try to fill that in. We know there's a lot missing in the SIB ship calculation because that's only going to tell us about adults. We're not going to ask children about their siblings. We're not going to have that in our sampling approach. So we're only expecting to know about adult mortality from these sibling survival methods.
We've been talking about the survival analysis in the Ukraine case that's going on now. We have another colleague that we work with who has a lot of data and background in Ukraine. And the problem with sibling survival analysis, both death and migration, is that people in Ukraine have very few siblings. So when you have these Eastern Europe, post-Soviet republics, they have in other countries with varying levels of fertility back to the 1970s, those are the adults around, and they just don't have siblings or to report their death to these things. And so that's why that friend thing is very interesting. So then people need to have enough information about one more comment on you said, like, what I said, you don't have a clue. This happens a lot in studying in conflict, where there's people who do it in all sorts of different places, and one here and one there, and there's not a whole lot of consolidation. See some research. Yes, what about that? There's not a whole lot of consolidation like moving forward on to work with that. We have all this kind of research work on demography and health and conflict. It is open to anybody. Members of it are welcome to like join that can be your sign up for it. Sometimes people give like capital and some of them presenting and work in private good discussion and do in-person workshops for me. So that kind of stuff is starting to happen when you have people in different places, when you have a talk and say, like your question, when we have instances that. So if you're interested, email me. Once a month on Zoom. Yes. Any other questions? Okay. Thank you. Nice to always see you guys.
Thank
Thank
you.
you so much.
Thanks for the invitation.